Hey folks, this calculus lesson is part 2 of antiderivatives. This is the trig half right here. So remember, antiderivatives is integration. It's the opposite of differentiation, you guys. So here's our derivative formulas, you guys. The derivative of a constant equals 0. So the integral of all, you're just going to work backwards right here. So let me go ahead and put the integration right here. So the integral of 0 is just going to be some kind of constant right there. Okay, we'll be mostly working with, like with this one, the derivative of, say this is 5x right here. It's just going to be 5. Okay, the integral of 5 would be 5x. It's going to be, we're going backwards. We're going to go from here to here, except we're going to add the plus c right here. Okay, this constant just says floated out in front of your derivative. Same right here. This constant just floats out in front of the integral right there. The k is the constant right there. And they're using k because we're using c as a different constant. They're just numbers, you guys. They just want you to distinguish that k is a different constant from c. Okay, so when you differentiate the sum or difference of two polynomials, then it's just the derivative of the sum or difference of both of those. And same with the integral, you just do them separately and add or subtract. Okay, say I had like x to the 5th right here. The derivative of x to the 5th would be 5x to the 4th. Okay, so you're going to go backwards over here. So the integral of this is you add the exponent by 1 and you divide by whatever n plus 1 is. Alrighty? So if this was x to the 5th, then this would be x to the 6th over 6. Don't forget your plus c's, you guys. When you integrate, you always have a plus c at the end when it's an indefinite integral. And these are indefinite if you don't have little numbers right here and right here. And that's coming up, you guys. That's in the next lesson or two. Okay, so if there's no numbers right here at the bottom of this integral and at the top of this integral, your answer is always going to have a plus c. All right? And don't forget it, you guys, because I know your calculus teacher will ding you points if you forgot it. I will. Okay, well, trig, you guys. Okay, remember trig, when you took the derivative of sine, it equals cosine. So if I did the integral of cosine, it would equal sine. All right, and the derivative of cosine equals negative sine, so the integral of sine would be negative cosine. Okay, don't forget it's plus c on these. So these are all going to be plus c. So I'm going backwards here, you guys. So the derivative of tangent is secant squared. So the integral of secant squared is tangent plus c. Don't forget your plus c. The derivative of secant is secant tangent, so the integral of secant tangent is secant plus c. Okay? Derivative of cotangent is negative cosecant, so the integral of cosecant is negative cotangent. Okay, cosecant squared. Sorry, this is cosecant squared. And similarly, the derivative of cosecant x is negative cosecant cotangent, so the integral of cosecant cotangent would be negative cosecant x plus c. Okay, don't forget your plus c's. I still know some of you guys are going to. All right, let's go. Let's integrate these. Find the indefinite integral on these, you guys. Okay, so the integral of sine x is negative cosine because the cosine, the derivative of cosine is negative sine. Okay, so it's going to be negative 2 cosine x plus c. Don't forget your plus c. Okay, that 2 came from this 2 right here. All right. This one right here, I'm going to separate this. I'm going to make this look like one of those integrals on the other page. I'm going to make this 1 over cosine times sine over cosine. Check it out. 1 over cosine times sine over cosine, because this is secant x and this is tangent x, and the integral of secant x tangent x is secant x. Here it is right here. The integral of secant x tangent x is secant x plus c. Okay, so the answer is secant x plus c. All right, how about this one right here? I have a polynomial and a trig function right here. So I'm going to separate them up. Okay, and then the integral of x squared is x cubed over 3, and the integral of sine is negative cosine, so it's negative negative, which became a plus cosine. Okay, don't forget your plus c. Okay, there's a plus c from this one and a plus c from this one. They absorb to 1 plus c. Okay, you know, like 2 plus 3 is 5. Well, 5 is a constant, so it's just some constant. Okay, so they absorb together to make one constant. Okay, this one right here, you guys, the integral of cosine over 1 minus cosine squared. Okay, this is an identity right here. 1 minus cosine squared is sine squared, so I'm going to make it, whoops, I should have put that there. Darn it, I didn't put that in there. This is sine squared right here. Okay, hopefully you can see that. I skipped that step right there. So I have cosine t over sine squared of t. So I made it 1 over sine of t There's my sine squared of t downstairs, and then cosine of t over sine of t. Okay, this is cosecant, this is cotangent. The integral of cosecant cotangent, you guys, is negative cosecant t. Don't forget your plus c. All right? Okay, now if you're having trouble with these, you guys, just remember your derivatives of these, okay? Remember, these are your derivatives, and so you're going backwards to get your integrals, okay? All right, so make that your friend, you guys. You're going to be using that a lot. All right, where are we? We're back to right here. Okay, so solve the differential equation. Here we go. Okay, so this one says the derivative is 6x squared, and f of 0 equals negative 1. They want us to find f of x. That's what they mean. Find f of x, okay, the original function. All right, so to get f of x, we integrate the derivative. So I'm going to integrate this derivative right here. So that's going to be the 6x squared. Going to integrate the 6x squared right there, and I'm going to add the exponent and divide by 3. So this is going to be 6x to the third divided by 3. That's going to be 2x to the third. So f of x equals 2x to the third plus c. All right, now I'm going to plug in this right here. F of 0 equals negative 1. So I'm going to plug in 0 right there for x equals negative 1. All right, so I get c equal to negative 1 right there. Okay, so c equals negative 1, so I can plug it in, and there's my function. F of x equals 2x cubed minus 1. Let's try one more of these, you guys. Okay, here's the double derivative, equals x squared, and then they give me the first derivative is equal f of 0 equals 6. I'm sorry, f prime of 0 equals 6, and then f of 0 from the original function, f of 0 equals 3. All right, okay, so let's work backwards. Let's get the first derivative function by integrating the second derivative function, okay? So the first derivative function is the integral of the second derivative function. So I get x cubed over 3 plus c. And I'm going to substitute in, okay, this is f of x right here. I'm going to substitute in this guy right here, f prime of 0 equals 6. Okay, so I'm going to put that in, and I get c equals 6. So f prime of x equals x cubed over 3 plus 6, okay, instead of the plus 3 now. All right, now this is f prime right here, so to get f of x, I integrate again f prime of x. Okay, so I'm going to integrate, I'm going to put this in there. All right, going to add an exponent, which is going to make it 4, and divide by 4. So I get that function right there, x to the 4th over 4. Going to add an exponent, so it's going to be 6x to the 1st over 1. I don't need the 1. Then don't forget your plus c. Okay, so f of x equals x to the 12th, because 3 times 4, plus 6x plus c. And then let's substitute in f of 0 now equals 3. Okay, so I'm going to plug in x equals 0, y equals 3. And I get f of x finally equals x to the 4th over 12 plus 6x plus 3. Isn't that stuff cool? I think this is fun. This is a fun chapter. Okay, take care, you guys. Whoops, time out. If you're in my class, that would be your homework assignment. Okay, take care, everybody.